two concepts together, let's see what happens. Here's a graph. Here's a function. So this is function f of x. And I have a point here, point P, and I have a point here, point Q. Yes, this is x. Can anyone tell us what this is? Unless we know it's y, but there is another way that I need. Other than, thank you very much. And we've done this before. This is very, very close. You can say that this doesn't look close at all. It's like 1.5 inches. True. Assume that we are zooming in. So we've been zooming in and they appear to be far away, but they're very, very close. Point Q is actually here. Okay. And can anyone give us the y coordinate of this point?
F of x plus h.
Of course. Thank you very much. Jackson, was it? Thank you. Of course. And now can anyone give us the rate of change between P and Q? The average rate of change between P and Q, what is it?
Would it be x plus h over x?
Is it f of x minus f of x plus h over x minus x plus h, but then you'd have to simplify?
Right. It's a difference quotient. It's a difference quotient, right? So it's f of x plus h minus f of x divided by x plus h minus x, right? So the average rate of change will be f of x plus h minus f of x divided by h. Stay with me. Now, imagine that this line gets, because Q gets closer and closer to P, it gets closer and closer to the tangent line at P. Would you agree? So if I move point Q closer and closer to P, let me show you another scenario right here. So here's P and here's Q. So this is P and Q. Here, this was the average rate of change between P and Q. But now here, this is the average rate of change between P and Q. Here's the third scenario. Now I'm bringing Q even closer to P. Here's P, and here's Q. Wouldn't this, as Q gets closer and closer to P, this becomes from a secant line to be just touching in one point, like a tangent. See the difference? This is a secant line. But this is a tangent line. Nothing to do with trigonometry. This is called secant because it crosses the graph in 2 points. This is called tangent because it only touches, or it has a common point, one common point with the graph of the function. So do we see why when Q gets closer and closer to P, eventually the secant line becomes the tangent line? So this is closer to becoming a tangent, this is almost a tangent, and this is a tangent. Would you agree, everyone?
Yes.
Okay. So then I have discussed the difference quotient. What does the difference quotient give us? It gives us the rate of change between 2 points. Okay, but what I'm really interested in is in the rate of change at one point, instantaneous. So I want the instantaneous rate of change. And I gave you that example. I gave it an example with driving to New York, and then you calling me and asking me what is your instantaneous rate of change. You want the rate of change at that moment. If I increase my production by 1,000 units, what is the change in the profit? I don't want to say if I increase from 1,000 to 2,000, what is the increase? No. I want to increase by 1,000. Tell me instantaneously what is the rate of change, how does the profit change? Not from 1,000 to 2,000. I want to tell you 1,500. Tell me how much the profit will change that instant. Okay, so for that, we will put the limit in front of the difference quotient. As age approaches how much? When Q gets closer and closer to P, what happens to H?
It gets closer and closer to 0.
Thank you very much. And this now is the instantaneous rate of change. And it has a name. And it's a function. And it's called f prime of x. So, what does f prime of x represent? Let's write it one more time. So, f prime of x is the derivative function of f of x, full stop. It gives the instantaneous rate of change of f of x, and this is very important. It gives the instantaneous rate of change of f of x wherever f of x is differentiable. Where it has a rate of change. A function may not have a rate of change. Is there somewhere where a function will not have a rate of change? Yes. This function will not have a rate of change at 7 because it doesn't exist at 7. If I can't move my car because it doesn't have an engine, you can ask me what is your rate of change and I'll say 0. Even 0 is a number, but I can't do anything. It has no derivative because the function does not exist. So one more time, f prime is the derivative function of f of x. It gives the instantaneous rate of change of f of x wherever f of x has a rate of change, or we say it's differentiable. In other words, it also gives not just the instantaneous rate of change, but is the same with, it gives the slope of the tangent line at any point. So the slope of this line is the same with the rate of change at this point. The slope of the tangent line here is the same with the instantaneous rate of change at that point. The slope of the tangent line here is the rate of change of the function at that point. Okay, so it changes because it depends on where I am. If I want to produce 1,000 units, or if I want to produce 2,000 units, or if I want to produce 3,000 units, the rate of change of profit with respect to the number of units I manufacture is different. So first let's talk about when is a function not differentiable. Not differentiable. It does, in other words, it does not have a rate of change. Instantaneous. Not differentiable in the following situations. Here is one. not continuous. It is differentiable everywhere here. It is everywhere here differentiable. I can create a tangent and find the slope. I can create a tangent and find a slope. I know the instantaneous rate of change everywhere, but not at this point. At 1, the function is not continuous. It has to have a unique tangent. It's a limit. If the limit from the left of 0 and the limit from the right of 0 don't exist or not the same, this does not exist. Right? We know that. If the limit from the left of 0 and the limit from the right of 0 are not, they don't exist, this limit is D and E. And that's exactly what happens here. The limit from the left, so if you want to, the slope here is whatever, and the slope here is whatever. They're not the same. They have to be the same number. Here's another example called cusp, like between two teeth. Something like that. This is a vertical tangent. A vertical tangent means that this is infinity or negative infinity. Doesn't exist. The limit doesn't exist if it's infinity or negative infinity. Here is another possibility called corner. So something like this. Look what happens at this point. Yes, this is differentiable everywhere here, but not at this point. It's differentiable everywhere here, but not at this point. It's differentiable everywhere here, but not at this point. How come? Because this is a number that is negative. The tangent here has a negative slope, and the tangent here has a positive slope. At this point, the function is not differentiable. It doesn't have a unique rate of change. And another one, it's something like this, which is only vertical tangent. So it's differentiable everywhere, but not at this point. Right here, the tangent is vertical, which means this left from the left and from the right are infinities, negative infinity. The limit does not exist. So we say infinite tangent. So that's how a function fails to be differentiable. So here's a question for you. If a function is continuous, does it imply that it's differentiable?
Yes.
If a function is differentiable, does it imply that it's continuous? Who said no for the first one?
I did.
Excellent. Here's why. Continuous, but not differentiable. Continuous everywhere, not differentiable. Continuous everywhere, not differentiable. So this is no way. No. But if I know that the function is differentiable, can I conclude that it must be for sure continuous?
Yes.
Yes. It's a must. Very good. So enough of that. Let's practice. On page 135. Let's choose. Please pick anything you want from 1 through 16. 135.
Could we do 2?
Absolutely. 3/2 x squared. So f of x equals 3/2 x squared. And the question here is asking us, find f prime of x. Here's a question for you. What type of function is it? Anyone I didn't hear yet? Like Gabby, Shvam, Noor, Brianna. Anyone?
Exponential.
If the power is an exponent, then yes. So an exponential function will look like this. When the power is the variable.
Would it be rational?
Say it again.
So would it be rational?
A rational function is x plus 1 divided by 2x minus 1. It has to have a fraction. If we say rational, it has to have a ratio, and it has to have x in the denominator.
It's quadratic.
Of course. Indeed, it's a polynomial function. It's quadratic. Is it continuous everywhere? Perfect. Does it have a cusp, corner, or infinite tangent? No, of course not. It's a continuous function. In this case, it's opening upward. It's a parabola. It's quadratic. It doesn't have any of these problems. It's always differentiable everywhere. Of course, it's continuous. No cusp, no corner, no vertical tangent. Awesome. So we can find f prime. We know for sure that the function has a rate of change, has a derivative at any point. Ready. How do I find what is the definition of f prime? How do I start?
You can start with just finding the difference quotient, right?
Correct, but I have to put everything together from the very beginning. So it has to be the whole spiel, everything. The two operators together, and I have to determine the limit. So this is carved in stone. Every time we are asked to find the derivative of a function using the definition, I have to write the limit. I have to write a difference quotient. Not difficult to remember, because these are two concepts that we've been talking about all along. Difference quotient and the limit. We know how this works. We know how this works. Now we only have to put them together. Okay, so it's 3/2 x squared. Good. I still haven't heard everyone. So again, Gabby, Noor, and Ram. Last chance. Okay, Savannah, I would like to help us with how do we start?
So everywhere. Wait.
Look here, I have to copy the limit operator.
Okay.
So you have to say limit as h approaches 0.
Okay.
Limit as h approaches 0. Now please tell me how much is f of x. So remember, f of x equals 3/2 x squared. I need to write f of x plus h. How do I write that?
So would it be 3/2?
Perfect. Yes.
X h squared.
That's it. Minus. And the function now, 3/2 x squared divided by h. Is everyone with me? I'm looking for my sip of water. Is everyone with me?
Yes.
Okay. What I would recommend to do to make our life easier, always remember, simplify and factor. I'm going to take 3/2 out. H approaches 0. I'll put 3/2 in front of the fraction line, or I can even put it outside as we learned in limit laws. Can anyone, again, other than Alex, square this for us? Shvam, would you square this for us? Noor, can you square this for us?
Yes. Would it be sorry, I'm looking at my notes. Would it be x squared plus 2xh plus h squared?
Good. Minus x squared divided by h. Good. What happens next?
And then on top, oh, we have to add Do we add the 3 squared x squared? Or
I
3
put-
over 2 x
I
squared?
put it in front. I factored
Oh,
it
okay.
in front.
Sorry, I missed that.
So what happens next?
You subtract the f of x.
I already did. It's right here.
Oh,
Mine my turn.
Get rid of x squared and negative x squared.
Good. Very good. I'll put the 3/2 in front. Limit sh approaches 0. What do we do next?
Do we factor with h next?
We factor out h. Okay. What is left in parentheses?
2x plus h.
Good. We simplify. And now what is the limit?
2x plus h?
Say it again.
I'm not sure. I said 2x plus h. I'm not sure if that's right.
But see, this is not the difference quotient. This is the limit of the difference quotient, and we know how to determine the limit. How much is the limit? Gabby?
The 2x plus h, but do you plug it in?
Okay, so what is the limit?
It was just h,
What are you plugging it in?
0.
For what?
Is it 2x?
Of course.